Alright, so let's get started on how to convert your CAD parts slash files into DXF files that can be cut out on the Waterjet. I'm recording this all in one go, so if I stutter a lot, I'm sorry. I'm not going to edit this. So first off, let's make sure everyone knows what we're actually talking about. What is exactly a waterjet? A waterjet uses a stream of highly pressurized water mixed with an abrasive material. For us, it's usually going to be garnet to manufacture parts with a continuous cross-section. So if you're ever at a store, or like a grocery store, and you see like those sliced pieces of fruit, those are most likely cut on a waterjet. And that highly pressurized water can easily cut through something like this because a slice of fruit you can cut with a knife. As soon as you start working with more tougher materials such as metals or wood, you have to mix in a abrasive material into the water stream to make sure that it can actually cut all the way through. In these two pictures, you can see there's a tube that's holding that abrasive material and that's getting fed into the water stream. That abrasive material is called garnet. It's essentially particles of sand, and those particles of sand are doing most of the cutting on the water jet. We're essentially eroding your piece very, very quickly. One thing we want to make sure is that the water jet can only manufacture parts with a continuous cross-section. What that means is that a part like this that has a pocket cut in the center of it cannot be manufactured on the water jet because I cannot tell the water jet to cut only halfway through your material. It has to go all the way through. It cannot go a certain percentage through. So if this pocket existed, it has to be something that goes all the way through your material like that. And that's what I mean by continuous cross-section. As you can see, if I took multiple slices of this material at multiple places, because that is all the way through, that cut, I will get the same cross-section every time I take a slice. Versus, if this is only a pocket, I'm going to get a different cross-section if I slice it here versus if I slice it here. So the waterjet cannot manufacture a piece like this. That's one thing to keep in mind. And then finally, the Waterjet uses DXF files, which is a very common file type that SolidWorks can export for you, and no other file type can be used. So you guys need to make sure that you're publishing DXF files for me that I will machine out on the Waterjet. So how do we actually make DXF files? First, do not use the old way. I do not know how many members of the team were there. I know Antonia used this method during her sophomore year, my senior year. The old way, very quickly, for this demonstration, I have two parts. They are essentially the same, test 1 and test 2, just the text is different, but two squares with some holes and some text in the center. And we will be using these parts for this demonstration, and we are also going to assume that these two parts are being used on two different subsystems slash mechanisms on the robot, made by two different people. That will come in later, but these two parts are going to be used. So again, please do not use the old way. So I can show very quickly, the old way involved taking this part and making a drawing from the part, and we can set the custom sheet size, and the part is 1 inch by 1 inch, so we can make it a 5 inch by 5 inch sheet, and then we can drag in the part, and then from the drawing we can export it as a DXF file. This is the old method, and we should really not be doing this method because it is not good. So let me pull up the DXF file. The DXF files will always be pulled up in something called eDrawings. It's this green application that your computer has if you have SolidWorks. You can see in this file, these center holes, or these holes have center marks in them, which is helpful for other machining applications. But for the Waterjet, we do not want these lines present in our drawing because the Waterjet will get confused and think, oh, I should be cutting here. You're going to end up with slits in your part where you do not want them. Along with that, this drawing has a scale, and if it's not set 1:1, and many times people forget to set it to 1:1. Right now it's at 2:1. When you export this file, it was initially a 1 inch by 1 inch. However, now if we measure this part, it is now 2 inches by 2 inches because the scale was set to 2:1, which is not good. So this method can be used to create DXF files. It's the way we used it during my 4 years on the team. I don't know why. It's really annoying because you have to make sure you delete all these center marks, and you have to make sure that the scale is set 1:1. And every time someone will forget to do that. Along with that, if you're making a custom part like a bracket, the bend lines on that bracket will confuse the DXF creation. So doing this method, please not do it. Hopefully no one on the team has even learned how to do this method because we have not used the Waterjet in 2 years. Instead of importing our part into a drawing, what we will instead do is orient our part in the SolidWorks viewer so we are looking perfectly at the face that we want to Waterjet and export directly from there as a DXF file, making sure not to change the view. So what we mean by that, let's actually work with primary part. So this is our primary part, and what we want to do is double hit spacebar and click on the face that we want to Waterjet, and from there we can file, save as, And then on the selection for what file type we want to export, we're going to hit .dxf, and we'll call this part 1 as well, or the other one was part 2. We'll call this part 1, and we will hit save. And SolidWorks will give us the option of what views we want to export, and by default, it's going to select the current view. And that's why we want to make sure we double hit spacebar and are looking perfectly at the piece. We do not want to use our scroll wheel or the arrow keys on our keyboard to look at the piece from a different direction, because if we did that, if we exported the part, you're going to get something like this, which the Waterjet will cut this out, but it will not produce the part that you want it to produce. So make sure when you're ready to export, look at the face that you are planning on machining, and then make sure current is chosen. Do not touch your scroll wheel or the arrow keys, the side arrow keys on your keyboard, and hit OK. And SolidWorks will give you a preview of what it looks like. That looks perfect, so we can hit save. And then if we load up part 1, you can see the part does not have the center marks for the holes, and if we measure it, it has not changed the scale. The part is 1 inch by 1 inch as we want it to be. Don't worry about the SolidWorks educational product. That's just a watermark that gets included because of the fact that we are using the student edition of SolidWorks. So that is the process of creating a DXF file. Now I want to get into the organization / naming scheme for the individual parts that you guys are going to be making. So in the GrabCAD, in FRC 2022, I've created a folder called Waterjet Cut Files, and we will have multiple rounds of water jetting because you guys will finish the CAD models for each of your mechanisms as we progress through the season. So initially you'll start off with your basic mechanisms like your drivetrain, your electronics. As you move on, you'll work on the climb and the hopper and the ball system, the shooter, etc. So we'll have multiple rounds. Inside of the rounds, I would like you guys, you can change this. Anything in underline means that you guys can change it, and we'll talk about that later. But inside of the round, you'll have multiple folders with the mechanism name, and you can include the name of the person responsible for the mechanism. And in that, you can have a folder for the material and the thickness of that material. And finally, in that folder, you can store the individual parts. So for this example, this part, the block with the text of test 1 and the block of with the text of test 2, this block we will consider to be a part of electronics, and the first block we will consider to be a part of drivetrain. And again, you don't have to put the names of the person, it will help later on. So with that, we can select our part, save as, and go into GrabCAD 2022 Waterjet files, the most recent round. So this is round 0, ignore this round later on, but you'll have round 1, which will be the first set of parts that you're going to cut out, which will be probably for your drivetrain. Round 2 will include parts for maybe bumpers, electronics, etc., etc. So go into the most recent round, go into the folder that you're going to be storing all of your parts, and then store your part in the correct folder, because you want to make sure you know what the part is made out of and the thickness of it, because the DXF file is just a 2D file. This 3D file, the part in SolidWorks, obviously I can measure the thickness. The DXF file, I have no way of knowing, is this supposed to be 1/8 inch thick or is it supposed to be 1/4 inch thick? So store it in that folder. And of course, I don't know the material that it's supposed to be made out of. With that, we can store our parts, and we also want to make sure we're following the naming scheme. For the individual parts, I don't really care what you guys call it. So let's say that this is a motor mount. The part name I don't really care about. What I do care about is that you label the material, the thickness, and the quantity of the parts that you're going to be cutting out. So again, part name, that's up to you guys. Just label it what the part name is in the SolidWorks file. But what I do care about is making sure that the material and the thickness and the quantity of it is there. So for this bracket, let's say it's a motor mount, and then what did I say, material, and we're going to say it's aluminum. And then finally, let's say we want 2 of these parts fabricated for us, and then .dxf, make sure that you select DXF as the export. And then again, current, hit check mark, and it will store the file. From there, we can create the DXF file for the other piece, which will be in the other subsystem. So save as. Again, navigate through GrabCAD, go into the most recent round, and then this one, we stored the first one in the drivetrain. in the drivetrain. This one we're going to say it's in the electronics, and again, aluminum 1/8 inch. And this part we will say what was not motor mount, motor controller mount. Obviously these are random names, but you guys get the gist hopefully. And then let's say we need 4 of these parts to be manufactured for us. And again, .dxf. It'll give us a preview. We can hit save. And now in these folders, in round 0, in the drivetrain, we have the file for the motor mounts, and then in the electronics, we have the file for the motor controller mount. Again, these are just random names I'm giving to this. And as you see, you have different folders with different materials and different thicknesses. So for most of the stuff, you guys are going to be working with aluminum that's either 1/8 inch or 090, 0.09 inch, and that's thickness. You guys could also, for bumpers, you're going to have wood, and that is going to be 0.75 inch. So you can make a folder like that. Obviously, that wouldn't go in the electronics folder, but you get the gist. You could also have steel, and you could have that in 1/8 inch as well. So make sure you create folders for the material. And again, I don't really care about this. You'll see why later, but it will be helpful for you guys, the individual members of the team. For this, however, we're only going to have aluminum 1/8 inch for both the electronics and the drivetrain. So once we export our individual part as a DXF, we now know how many we describe how many that we want. We now have to create a master file. So a master file is all the parts put into one singular DXF file, and that is the file that I will personally upload directly to the Waterjet. Before, we would have our mentor do this for us because we would not know the size of the material that we're going to be ordering. However, this year, because you guys are going to be supplying the material yourself, you know the size and the shape of the material, so you can create the master file from the get-go, and that way I don't have to do it. And also, if I did it, I may mess up. With you guys creating it as the owners of your mechanism, it's a higher chance that you guys don't mess up this file. First thing is that we want to keep parts 1 inch away from the edge. So most of the time, the Waterjet can accommodate a 4 foot by 4 foot sheet. Again, you guys are going to be working with 090 aluminum or 1/8 inch thick aluminum. So you can have a 3 foot by 3 foot, 3 by 4, or 4 by 4. Obviously, the larger sheet you purchase, the better it is price-wise. For 090, you have 3 foot by 3 foot and 3 by 4. You do not have a 4 foot by 4 foot. And what I mean by 1 inch away from the edge, when you're creating your master file, when you put a part into the Waterjet, you have to secure it. And you can see these are some clamps that I have securing the part, and that edge cannot be cut on because the Waterjet cannot go there because those clamps are in the way. And you can see that's me making sure the piece cannot move. So those clamps have to be there to secure the part to the Waterjet bed, and in doing so, we cannot cut 1 inch from the edge of our part, of our stock material. What that means, if this is our huge sheet of material, our huge piece of aluminum, this perimeter of it cannot be cut on because of the fact that I'm going to be using clamps to secure it on this edge. So please do not add parts in that edge area, because I will not be able to secure your sheet to the Waterjet. So to help you guys with this, another thing is to help you guys with this, I have created some grid files in the Waterjet folder, which you may have seen. So these are grids, and then you have a 3 foot by 3 foot, a 4 by 3, and a 4 by 4. So let's just work with the 3 by 3. And it's going to look like a lot when you load it up. And this is essentially a bounding box, the outermost perimeter. And you can see I've already accommodated for that 1 inch gap. So it's instead of a 36 by 36, a 3 foot by 3 foot, it is instead 34 by 34 because you've lost a 1 inch perimeter on each side. And then along with that, inside of here, I have center lines. These are construction lines that are distanced exactly 0.25 inches apart. And as you can see, you want to make sure that when you're placing parts in a master file that they are 1.25 inches away from each other because of the fact that we have to add tabs to the parts when we're cutting them out. Tabs are this. As you can see, the Waterjet has completed cutting out this piece, the test number 2 piece, and you can see it's still connected right there to the overall sheet of material, and we need it to stay connected to material because if we cut it out completely, once the part is completed cutting out, there are these vertical slats in the Waterjet, And if the piece is smaller than the distance between those vertical slats, it will just fall right between them. So we add those tabs to keep the piece secured to our overall piece of material. And that's why we need to make sure we have at least a 1/4 inch distance from each part, because those tabs are going to take up a little bit of space. If I had a part located right here, that tab would interfere with that part. So we want to make sure that we're distancing our parts properly. And then also, we'll come back to that later, but we want to keep parts 1 inch away from the edge. If you use the grid, that essentially means keep the parts inside of this bounding box, do not go outside of it, and then keep adjacent parts at least 0.25 inches away from each other. And that's to accommodate for tabs. And again, these grids, they look like a lot, but I consider them super helpful. But if you guys do not want to use them, you don't have to. Just make sure you are abiding by these 2 rules. So to actually create the master file, let's pull it up. We go into our individual subsystems, and these will be created. So in this example, I have Antonia assigned to the drivetrain. So Antonia will be responsible for creating the master file for that drivetrain. So she will most likely have a bunch of parts listed in here. But right now we only have the 2, or we have 1 part with 2 copies. So if we zoom in and we take this DXF file and we just simply drag it into SolidWorks, it will then render the part in SolidWorks, and we can zoom in and we can place it right in the corner. And then it will allow us to place multiple parts, which is helpful because this part, we are going to have 2 of them. So we can place our second part right here. And then once we inserted our blocks, you can see those blocks are now in a different sketch. So if we had more parts, we would keep adding them and making sure that they are exactly 1 square away from each other to make sure we keep that 0.25 inch distance and we don't interfere with any other parts. So for right now, we only have these 2 parts. So this will be the master file for the drivetrain, which Antonia would be responsible for. And it would be the master file for the aluminum 1/8 inch thick. Once we have these parts inserted and they're spaced apart and they're not outside of our bounding box, we can go ahead and we can actually delete this. I don't really care about it. Exit sketch. And then we can delete the grid. And don't worry about the error that it gives you. It's not of a concern. And then from there, we can export this. And this will be our master file for the drivetrain. So save as. Go to Waterjet cut files, drivetrain. This will be the master file, aluminum, or master file for the drivetrain. And this is the one that is for the aluminum. And then again, mark out the material, the thickness, and then also the quantity. Usually the quantity for the master file is always going to be 1. Sometimes it may be multiple, but you should just mark it out just in case. And then again, we want to make sure we are exporting this as a .dxf. And then make sure current is checked. And this will export 2 of these parts. And again, this is a very basic example. On a real master file, you're probably going to have a bunch of parts and they're going to be all unique. So the gist is you want to make sure that they are spaced at least 0.25 inches away and they are within that bounding box of a bounding box that is 1 inch smaller on each side from the overall material that you're going to be using. So for this 36 by 36, the 3 foot by 3 foot sheet, it's inside of a 34 by 34 inch box. Once that's done, do not save this because that would save the grid file. You can get rid of that. And now for Antonia and the drivetrain, we have the individual parts stored as well as the drivetrain master file. Again, drivetrain master or master file. And it's probably actually best to label that this is going to be the round 1 master file. If you forget to include some parts of the names, don't worry. Also, I don't technically care about any of this stuff. You guys will see why later on. But it is going to be helpful for the members of your team. So I'm following that naming scheme. So now let's go ahead and create the master file for the electronics. And we only have 1 master file because we have aluminum and 1/8 inch. The number of master files that you should have should match the number of folders that you have. So if we had a folder, steel, 0.125 inch, 1/8 inch thick steel, we would have another master file, round 1, and instead of aluminum, we would have steel. But luckily for us, we only have aluminum, so we only have 1 master file. So for electronics, we can again, first can open the grid file, which helps us align everything. And again, choose the 3x3. And then to create the master file, we go back in. And this one, we know it's ×4. So we're going to have 4 copies of this. So drag and drop it in. And then start positioning it like so. So there are the 4 parts. We can check mark, exit, and then delete the grid background. Ignore that. And then save as. And then if we go into round 0, electronics, now we are going to have electronics master file for the round 1, and this is aluminum and 1/8 inch thick. Or not .dx up there. And we'll hit export. And there is our master file for the electronics. And we can get out of here. Again, do not save because I'll save the grid file. So now we have our master files created for all of the individual subsystems for this round. And this is most likely going to be created by the owner or person responsible for that subsystem, person that designed that subsystem in CAD. And that way you can make sure, like if you have a bunch of parts, even if you label it perfectly, that person may realize, oh, hey, I actually should probably make a couple extra of these parts, or they may realize that they did something incorrect during their naming scheme. So let's say that they forgot, and instead of ×2, they said ×3, or let's say ×1, they forgot to include one instance of that part. If someone else was creating the master file, they would forget to include that. So the master files for the individual subsystems / mechanisms should probably be created by the person who designed that mechanism in CAD. And then once the master file is created for all of these subsystems, we can now create the overall master file that will be that I will actually cut out. So again, file open. Let's pull up our grid. And again, we're just saying we're going to cut out a 3 foot by 3 foot sheet. Now we can take the master file for the drivetrain, copy that over. Actually, let me copy the larger one over first. So the master file for the electronics, which has 4 instances of this. And then position that in the corner. And then the master file for the drivetrain. And again, this is the master file that is going to be essentially for the aluminum 1/8 inch thick for round 1 cutting. If I had another master file in here, well, let's say instead it was steel. I would not insert this master file into the master file that I'm creating right now because the material do not align. Also, if let's say it was aluminum, but instead of 1/8 inch thick, it was instead 090, that material difference, I would also not drag it into this master file because it's not going to be correct. But because both of these are aluminum and 1/8 inch thick, we can drag them both in. And again, we are using the grid as a way to ensure that we are spacing them enough apart that we are not going to create a file that cannot be manufactured on the Waterjet. And then once all of our master files for the subsystems are inserted and they are for the right material and the right thickness, we can finally first delete this, ignore that, and then we can hit save as. And then finally, this is the file that I will actually care about. This will be stored in the folder round 1, round 2, etc. And this master file should just be called master file and then the material and the thickness. And this is the only file that I will personally care about. So we'll call this master file for the aluminum and 1/8 inch thick, and then make sure we store it as a .dxf file. And then the file you can see is stored right here. One thing that I skipped over uh, these parts that I actually designed would actually not be manufacturable on the Waterjet. The Waterjet, even though it looks like the water coming out of it is a perfect line, it is actually a cylinder. That cylinder has a radius. It's called a kerf width, and that radius is 0.021 inches, meaning that if you had a hole, so the diameter of the cylinder that's coming out is 0.042 inches. So if you had a hole on your robot that you wanted to make 0.04 inches in diameter, smaller than the diameter of the Waterjet cylinder, then that hole would be impossible to manufacture on the Waterjet. Usually this is not a concern for you guys because a 0.04 inch diameter hole is a 1/25th drill bit size. Usually drill bit only go like down to 1/16th. So usually you're never gonna have to worry about this. For this text I created, you can see that text is very small given that this is only a 1 inch by 1 inch square. And when I was actually manufacturing this, you can see that text, that's where the Waterjet is going to be cutting. And you can see that red is kind of going everywhere. It's not going to create something that's nice. So, and you can see over here, the tool offset is 0.021 inches, and you have to account for that. So any small feature that is smaller than that value cannot be manufactured on the Waterjet. It's impossible. And just to show you, you can see when the piece actually came out, the text was illegible. The holes and the overall size of the square, they came out perfectly fine. The text, because it was so small, the Waterjet was not able to manufacture it. Another thing that is pointed out, make sure that it has a continuous cross-section. Waterjet can't manufacture pockets. So, in summary, we have created the files for the round 0 of waterjetting. For you guys, it'll be round 1, round 2, round 3. What I will be doing on my end is I will go into the GrabCAD, into FRC, I'll go into Waterjet cut files, I will go into the most recent round. So if round 1 and 2 have been completed, I will go into round 3. Once I go into the round, I'm not going to care about anything that is in these folders. I just want to see master files. I would like to see the material and the thickness of the material that I'm going to be cutting on. And these are the only files that I care about. Please do not include any other files, only have folders in here. And again, these folders, you guys can organize however you want. You don't even have to put all your DXF files for your individual parts here. You can put that into a different location. But the way that it's organized right now, creating master files, anyone can technically do that because they can just go into the subsystem that they're creating a master file for, look at what materials they have. So if it's aluminum 1/8 inch, or if they had aluminum 090 or steel 1/8, they would know they're creating the number of master files they're creating for that mechanism is the number of folders that are present in that mechanism. So for us, it's just aluminum 1/8, and it's ×2 of one individual part, which we created a master file for. And then finally, you're going to integrate all of the master files for the different subsystems on your robot into a large master file as we did here. And that's the master file that I will actually care about and the file that I will load into the Waterjet machine. I will not do anything. If you guys forget to include a part in this master file, I will not notice it because I'm not going to index through all of your folders and make sure that all the parts are included. The only thing that I'm going to do is open up this file and check that the parts aren't too close to one another, that there's nothing weird that I see, and that the maximum distance is not larger than the sheet of material that you're going to be using for that cut process. One thing to note, do not worry if the parts that you're going to be manufacturing in one round of Waterjet do not take up the entire sheet of material. If you only take up if this is your sheet of material and you're only going to use up this much space, do not worry. That's still perfectly fine. We'll manufacture that in round 1, and then the rest of the material we will store for a later usage. But the only thing you cannot do is, if this was the 36-inch piece, this has to be a 34-inch box. And let's say this is a 36-inch box. Sorry for the drawing. You cannot tell me to manufacture anything on this 1-inch edge because I will have to clamp down the piece there, and the Waterjet can, if I told it to cut there, it would collide with the clamp that is holding the piece down. So do not do that, please. And again, I only care about the file that I'm going to immediately see as soon as I open the round number, the most recent round. The folders contained in here and how you guys organize that, it's up to you. Doesn't really matter to me. The only thing I care about is these master files, and just label it as the material and the thickness. And then I'm going to assume if you should not have to label it as ×2 or like ×3. It should just be ×1. So labeling it as ×1 is redundant. And then if you guys had a different master file, And let's say this one was for, let's say it's for bumpers, so it's going to be wood, and then 0.75 inches, 3/4 inch thick for your bumpers. When I load up the round 0 and I look at this, I see that I have two master files, one for aluminum 1/8 inch thick and one for wood 3/4 inch thick. That way I know I'm going to be doing two cuts, one on a sheet of aluminum and one on a sheet of wood. Also, if you're manufacturing a ton of parts in one go, and those parts cannot fit into one singular sheet of 4 foot by 4 foot or 3 foot by 3 foot aluminum, then of course create a new master file with the parts that cannot be fit onto that one sheet, and then you can just label this as number 2 for aluminum. And this will indicate to me that I'm going to be doing two cuts on aluminum. The first cut will take up the entire sheet. The second cut will go onto a different sheet. I cannot fit everything into a singular sheet of material. So that's how you guys will be creating master files. Again, please make sure to include all of your parts in the master file. When I open them, I'm not going to do anything besides make sure that they are the proper size, that I can actually manufacture them. Beyond that, if you forget to include a part, then that's on you. Once I have finished manufacturing the parts for a certain round, I'll go into here and rename the folder and then say completed. And then also I'll write the date. So today's the 11th, and then completed on 1/11. Okay, well, it's not going to allow me to do it because I have a bunch of the files open. But I will essentially write completed, and then I will create a new folder, and then that will be round 1. And then for the next round, you would put all of your files in here. And for this, it will be round 2, round 3. Let me know if you guys have any questions. Apologies for the stuttering, but hopefully this makes sense on how to water jet.